Good day, everyone. So for this video presentation, I'll be presenting our machine problem 9.2, the numerical integration in advanced mathematics and chemical engineering. So for this group, the members are Abanilla Hazel J, Arcelia Janko D, Daniels Luis Alfonso, Mendoza Karen Ira, and Ramos Ryan Cal. So for this machine problem 9.2, we are instructed to make a very user-friendly MATLAB program that can numerically estimate the following defined functions. The first function is the j is equals to the integral of 1 over x dx to the from the lower limit 1 to the upper limit 2. And for the second function is equals to the j is equals to the x exponential of negative x squared dx from the lower function 0 to the upper function 1. So the user should be presented with an interface telling him which function to choose and asking him which method to apply. The program should ask the user which functions does he want to solve and which method does he want to use to solve the chosen function. The user should be able to choose from the following methods. First is the trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, and 5-point quadrature rule. So without further ado, let's use the MATLAB program. So for the clearer presentation, I'll be using two tabs. On the left tab is the command window, and on the right tab is the program or the MATLAB program that we will be using. So without further ado, let's start to use the MATLAB program. So first, we're going to click the run. Then we will choose the desired method of numerical integration. By the way, for this part, we will going to evaluate the first function first before the second function. For the trapezoidal rule, we'll use the function 1. And for the trapezoidal rule, the value of the function integral of 1 over x with respect to x from 1 to 2 determined using the trapezoidal method is 0.75000 units. Computing for the percent absolute error, we get the 8.20%. Next is the Simpson's 1/3 rule. We choose the Simpson's 1/3 rule. Then we will type the function 1 over x. Then the lower limit, which is 1. Then the upper limit of 2. So the resulting estimated value of the function using Simpson's 1/3 method is 0.69444 units. The true value of the function is the 0.693147 units. Thus, the percentage error is 0.187156%. Moving on to the next method, we will then again run this program, then click the Simpson's 3 over 8 rule. So here we are asked what function do we want to solve. So we're going to solve the first function. The value of function 1 determined using the Simpson's 3/8 rule is 0.6938 units, and the percent error is 0.0870%. Lastly, for the 5-point quadrature rule, we will choose the function 1. Thus, the value of function integral of 1 over x with respect to x from 1 to 2 determined using the 5-point quadrature rule is 0.69325 units. Computing for the percent absolute error, we get 0.01541%. So among the four methods, this 5-point quadrature rule has the least percent error. Moving on to the second part, we will now then going to evaluate the second function. Again, we will run this MATLAB program. Then we will choose the trapezoidal rule, choose the second function. For this part, the value of function integral of x exponential negative x squared with respect to x from 0 to 1 determined using the trapezoidal rule is 0.18394 units. Computing for the percent absolute error, we get 41.080233%. Next is the Simpson's one-third rule. For the Simpson's one-third rule, we're going to type the function x exponent of x negative x squared then we will going to enter the lower limit 0 and the upper limit 1. So upon using the MATLAB program, the resulting estimated value of the function using Simpson's one-third method is 0.320914 units. The true value of the function is 0.316060 units, and the percentage error is 1.535537. Again, we will run this MATLAB program for the Simpson's 3/8 rule. Then click the Simpson's 3/8 rule. So here we are asked what function do we want to solve. We will enter 2. Thus, the value of the function 2 determined using Simpson's 3/8 rule is 0.3181 units, and the percent error is 0.6564%. Proceeding to the last rule, which is the 5-point quadrature rule. We will click this 5-point quadrature rule and the function 2. So upon using the MATLAB program and upon clicking the 5-point quadrature rule, we have the value of function integral of x exponential negative x squared with respect to x from 0 to 1 determined using the 5-point quadrature rule is 0.31629 units. Thus, our percent absolute error is 0.07167%. Again, this 5-point quadrature rule has the least percent error among the 4 methods. So that concludes our machine problem 9.2 using the very friendly user MATLAB program. Thank you for listening.